Welcome back to Against the Grain, the channel dedicated to the Mavericks, the rebels, the engineers who were told no, and did it anyway. We love the stories of breakthroughs, of machines that redefine what's possible. We celebrate the Wright brothers, Kelly Johnson, Burt Rutan. But between those famous names lie 1,000 forgotten battles, fought not on the battlefield, but on the drafting board, in the wind tunnel, and in the soul-crushing confines of the briefing room. History is littered with revolutionary ideas that were almost strangled at birth by committees, by experts, by men whose vision was limited by the rule book. Tonight, I'm telling you one of those stories, my story. It's about a time when American air power was hitting a wall, literally. A wall of compressed air that was shaking our best fighters apart, limiting our speed, and giving the enemy an edge. The greatest minds in aeronautics were stumped, throwing millions at solutions that weren't working. And then there was me, a junior engineer, a nobody, with an idea so radical, so counterintuitive, that it wasn't just dismissed, it was laughed at. They called me a joke in that briefing room, patted me on the head, and told me to get back to calculating fuel efficiencies. But that joke, that scribbled drawing born of desperation, it held the key. It was the design that would shatter the wall and redefine the very meaning of speed for American fighter aircraft for decades to come. This is my boss told me you'll crash every plane. Now pilots are breaking records because of me. Before we break the sound barrier on this one, I need you to run your pre-flight checks. First, hit that subscribe button and ring the notification bell. It's the only way to make sure you catch these stories of defiance and innovation. Second, hit that like button. It tells the algorithms that this history matters and needs to be seen. And finally, drop a comment down below. Let us know what country and city you're watching from. It's incredible to see our global audience of aviation and history enthusiasts. All right, pencils down. Let's go make some noise. My name is Sam Holloway, and back in the late 1950s, I was just another slide rule jockey lost in the sprawling, sun-baked high desert labyrinth of Edwards Air Force Base. I wasn't a pilot with nerves of steel, testing the limits in the sky. I was a civilian aeronautical engineer, barely 30, working for the Flight Test Center, analyzing data, running simulations, and mostly trying to stay out of the way of the real titans. The test pilots, the senior engineers, the men who had designed the very jets that were screaming overhead, pushing the ragged edge of the envelope. It was the golden age of jet aviation, a time of incredible progress, but also brutal limitations. We were building planes faster than we truly understood how to fly them. The Century Series fighters, the F-100 Super Sabre, the F-104 Starfighter, the F-105 Thunderchief, they were marvels of raw power, capable of supersonic speeds in level flight, something unthinkable just a decade earlier. But they were also killers. They were unforgiving beasts, prone to vicious stalls, uncontrollable spins, and a terrifying phenomenon called inertia coupling, a kind of high-speed, high-altitude tumble that could rip a plane apart before the pilot even knew what was happening. We were pushing speed, but maneuverability, agility, control, that was lagging dangerously behind. The fundamental problem, as every engineer understood it, was stability. For centuries, aircraft design had been predicated on the principle of inherent stability. A stable aircraft wants to fly straight and level. If it's disturbed by turbulence or a control input, it naturally wants to return to its equilibrium state. Think of a well-designed paper airplane. It just glides smoothly. This inherent stability makes a plane easy and safe to fly, especially for pilots dealing with the stress of combat or bad weather. But there's a trade-off. A fundamental compromise baked into the laws of physics. Stability is the enemy of maneuverability. A highly stable aircraft resists changes in direction. It's sluggish. It takes time and effort to force it into a turn, a roll, or a climb. To make a fighter truly agile, truly responsive, capable of snapping onto a target or dodging a missile, you ideally want the opposite of stability. You want instability. An unstable aircraft wants to depart from straight and level flight. It's incredibly sensitive to control inputs, capable of maneuvering with breathtaking speed and precision. Think of balancing a broomstick on your hand. It's inherently unstable, constantly wanting to fall, But that very instability allows you to make tiny, instant corrections to keep it balanced, or to flick it in any direction you choose. The problem? An unstable aircraft, left to its own devices for even a fraction of a second, will depart controlled flight and tumble catastrophically. It requires constant, minute, superhumanly fast corrections from the pilot just to keep it pointed in the right direction. No human pilot possesses the reaction time or the processing power to safely fly a truly unstable aircraft, especially not at supersonic speeds, pulling high G-forces in the middle of a dogfight. So, we were stuck. We built stable, safe, but relatively sluggish fighters. Or, like the early Century series, we pushed the stability margins lower, creating planes that were faster and slightly more agile but dangerously close to the edge, unforgiving of the slightest mistake, earning grim nicknames like the Widowmaker. My job was to analyze the data from test flights, trying to understand these limitations. I'd pore over oscillograph printouts, looking at control surface deflections, G-loads, pitch and yaw rates, trying to find patterns in the moments just before a plane went out of control. And I started to notice something. The problems weren't always aerodynamic in the classical sense. It wasn't always a simple stall or a predictable spin. It was often a problem of control. The pilot would make an input, but the plane's reaction would be delayed or exaggerated, or coupled with an unwanted motion in another axis. The mechanical control systems, rods, cables, pulleys, hydraulic actuators, they had inherent friction, lag, elasticity. They were good, but they weren't instantaneous. And at supersonic speeds, dealing with rapidly changing aerodynamic forces, instantaneous was becoming the minimum requirement. I wasn't the only one thinking about this. The concept of fly-by-wire, replacing the mechanical linkages with electrical signals, was starting to be explored, mostly for large, slow-moving bombers, where stability augmentation was needed. But for fighters, it was seen as heresy. Pilots, especially the grizzled veterans who ruled the roost at Edwards, believed in feel. They believed in the direct, physical connection to the control surfaces, the subtle feedback transmitted through the stick and rudder pedals that told them what the plane was doing. Electronics? They were unreliable, prone to failure, vulnerable to battle damage. They lacked the soul, the feel, that a pilot needed to truly master his machine. But I wasn't a pilot. I was an engineer, and I saw the potential. Electronics were fast, microsecond fast. They didn't have friction or lag. They could be programmed. They could make corrections faster than any human pilot could even perceive. What if we didn't just augment the controls? What if we embraced instability? What if we designed a fighter that was intentionally, radically unstable, a true, balanced broomstick, making it potentially far more agile than anything flying? And what if we used a fast-acting, electronic flight control system, not just to augment stability, but to create it, to act as the pilot's superhumanly fast hands, making thousands of tiny corrections every second, keeping the unstable airframe balanced on the head of a pin, while interpreting the pilot's commands and translating them into precise, instantaneous maneuvers? It was a crazy idea. It flew in the face of centuries of aerodynamic convention. It required trusting black boxes over pilot intuition. It required designing an aircraft that wanted to crash and then building an electronic safety net to catch it perfectly every single time. It was, in short, terrifying. But the potential? A fighter with the stability of a bomber in cruise, but the agility of a hummingbird in combat. It was the holy grail. I started sketching, not aerodynamic shapes, but control loops, feedback diagrams, sensor inputs, actuator outputs, gain scheduling based on airspeed and altitude. I wasn't designing an airframe. I was designing a nervous system. I realized the key wasn't just replacing the mechanical links. It was creating a variable response. At low speeds, or during landing, the system could provide high stability, making the plane docile, easy to handle. But in combat, at high speeds, pulling Gs, The system could relax the stability, allowing the plane's natural instability to work for the pilot, resulting in lightning-fast response rates. It was relaxed static stability, RSS, coupled with a full authority, variable gain, fly-by-wire control system. I knew, on paper, it could work. I built a crude simulation on the base's primitive analog computer, feeding in the aerodynamic data from an F-100. The results were astonishing. The simulated RSS FBW F-100 could perform maneuvers that would tear the wings off the real aircraft, simply because the control system could react before the instability became dangerous. It was faster, tighter, more controlled, better. I had to tell someone. I requested a briefing, not with the top brass, not yet, just with my section head, the Chief of Stability and Control, Colonel Rex Bulldog Johnson. Bulldog was everything I wasn't. ex-WAT P-47 pilot, credited with 6 kills. A man who believed that the best flight control system was a pilot's hands, feet, and calibrated ass. He distrusted anything more complicated than a cable and pulley. He saw electronics as delicate, unreliable, unproven. He was also my boss, and he held my career in his calloused, capable hands. I walked into his office, a cramped space filled with models of planes he'd flown, and the smell of old coffee and cigar smoke. I had my charts, my simulation printouts, my diagrams. I was nervous, but also brimming with the righteous certainty of a true believer. I laid it all out. RSS, FBW, variable gain, the simulation results, the potential for unprecedented maneuverability. I talked for maybe 15 minutes, my voice gaining confidence as I laid out the logic, the physics, the necessity of this leap. Bulldog just sat there behind his massive steel desk, leaning back in his chair, puffing on a thick cigar, his eyes narrowed, giving nothing away. When I finally finished, breathless, expectant, he just stared at me for a long, silent, smoke-filled minute. Then, he slowly, deliberately took the cigar out of his mouth. He leaned forward, placing both hands flat on his desk. And he laughed. It wasn't a chuckle. It was a deep, loud, booming, derisive laugh. The laugh of a man who had just heard the stupidest, most dangerous, most utterly insane idea of his entire life. "Holloway," he finally choked out, wiping a tear from his eye, the laughter still rumbling in his chest. "Son, I swear. Sometimes I think you engineers just sit around dreaming up new ways to kill my pilots." He picked up my carefully drawn diagram of the electronic control loop. This, fly-by-wire, relaxed stability. This isn't engineering, this is science fiction. You're talking about taking the pilot out of the loop. You're talking about trusting some box of wires and vacuum tubes, transistors were still new and mistrusted, to keep a goddamn supersonic fighter from tumbling end over end. Are you insane? "Sir," I started, "the simulation show." "Simulations?" He scoffed, waving the diagram dismissively. "Son, I don't fly simulations. I fly airplanes. Airplanes with hydraulic fluid, with cables, with feel. You lose an engine, you lose hydraulics, you take battle damage in a real plane. You can still fight it. You can wrestle it back. This thing." He tapped the diagram again. "You lose power to this black box. You get a short circuit. A vacuum tube blows. What happens then, Holloway? Tell me. What happens when your electronic brain fails at Mach 1? 5. Pulling 6 Gs? He leaned across the desk, his eyes boring into mine, the folksy humor gone, replaced by cold, hard command authority. "I'll tell you what happens. The plane departs controlled flight in less than 1/10 of a second. The pilot becomes a passenger. He dies, instantly. There's no recovery, no wrestling it back, just gone." He stood up, towering over me. "Your idea, Holloway, is not just stupid. It is lethally irresponsible. You haven't designed a flight control system. You've designed an electronic suicide pact. You try and build this. You try and put this anywhere near one of my test aircraft. And I promise you, you'll crash every plane you touch. You'll kill pilots. You'll set aviation back 20 years. He walked to the door and held it open. "Now get back to your stability derivatives and your fuel charts. And don't ever bring me this electronic nightmare again. You are a joke in that briefing room if you push this. You are done. Dismissed. I walked out of that office, my face burning, my carefully constructed world shattered. He hadn't just rejected my idea. He had condemned it. He had forbidden it. And he had, with absolute certainty, predicted disaster. You'll crash every plane. The words echoed in the hallway, a death sentence for my ambition. But even as the humiliation washed over me, a colder, harder core of defiance remained. He was wrong. The risk wasn't in the electronics. The risk was in not embracing them. The risk was in staying tethered to the past. While the future of air combat demanded a leap we were too afraid to take. He had called me a joke. He had predicted disaster. Fine. Let him. I wasn't just going to prove him wrong. I was going to redefine the sky. Bulldog's laughter didn't just echo in the hallway. It took up residence in my skull. For weeks, it was the soundtrack to my failure. You'll crash every plane. The words became a mantra, a taunting, relentless ghost that haunted my waking hours and infiltrated my dreams. I'd be running fuel consumption calculations, and the numbers would blur, replaced by the image of a tumbling starfighter, its wings shearing off in a blur of fire and smoke. Officially, I was a ghost. I was assigned to a series of mind-numbing, dead-end analyses, calculating the fatigue life of landing gear bolts, plotting the thermal expansion of canopy plexiglass. It was make work, a professional purgatory designed to keep me far away from anything that mattered, a clear message from Bulldog to me and anyone else with stupid ideas. The briefing room joke had become a career reality. I was isolated. The other junior engineers, who had once been friendly rivals, now avoided my gaze in the cafeteria. I was the guy who had challenged the colonel, the pilot hero, with a box of wires and been laughed out of the room. I was contaminated. But Bulldog had made one critical miscalculation. He thought humiliation was a sedative. For me, it was a stimulant. His laughter hadn't broken my spirit. It had forged it into a cold, hard, diamond point of certainty. He was wrong, and I was going to spend every last ounce of my energy and intellect proving it. I couldn't do it alone. My simulation on the analog computer was a good proof of concept, but it was just that, a simulation. To take the next step, to build a physical prototype of my black box, I needed hardware. I needed components, test equipment, and most of all, a space where a colonel's shadow didn't fall. My salvation came in the form of a man who smelled perpetually of solder fumes and burnt coffee, Master Sergeant Frank Sully Sullivan. Sully ran the avionics repair depot, a sprawling, chaotic kingdom of green metal workbenches, whirring oscilloscopes, and the dissected guts of every electronic device in the Air Force inventory. He was an enlisted man, a lifer, a sarcastic genius who had forgotten more about practical electronics than most PhDs ever learned. Crucially, he had a deep and abiding distrust for officers who thought a pilot's license was a substitute for an engineering degree. I found him one evening, long after the official workday had ended, hunched over the mangled remains of a radar unit that had been hit by lightning, a soldering iron in one hand and a lit cigarette dangling from his lips, a flagrant violation of about 6 safety regulations. "Sarge," I said, my voice feeling small in the vast humming workshop. He didn't look up. "If you're here to tell me again that the MTBF on these damn radar sets is a work of fiction, you can save your breath, Holloway. I'm living the proof." He knew my name. Of course he did. He knew everything. "No, Sarge," I said. I need a favor. Off the books." That got his attention. He finally looked up, his eyes, magnified slightly by his thick glasses, narrowed in suspicion. "Off the books? You're Bulldog Johnson's fair-haired boy. Everything you do is on the books, usually in triplicate." "Not anymore," I said, the bitterness creeping into my voice. "The colonel and I had a disagreement about the future of flight control." Sully smirked, a cloud of smoke escaping with the sound. "Heard about that. Something about you wanting to replace pilots with vacuum tubes." "Something like that," I admitted. "He thinks my idea is a suicide pact." "And is it?" Sully asked. his gaze returning to the circuit board, but I knew he was listening intently. "No," I said, the certainty rising in my chest. "It's the opposite. It's the only way we're going to stop crashing these damn things. But to prove it, I need to build it. A real hardware prototype. And I can't do it in my office. I need a ghost lab, a place to work, and I need parts." Sully was silent for a long moment, the only sound the hiss of his soldering iron. He was weighing the risks. Harboring a disgraced engineer, aiding an unauthorized project. It was a court-martial offense for him, too. But I also knew Sully was a tinkerer at heart, a man who loved a good technical challenge more than he feared a colonel. And maybe, just maybe, he thought I was onto something. "All right, Holloway," he finally grunted, not looking at me. "Back corner of the boneyard, warehouse 7. It's full of junked F-86 parts and obsolete test gear. No one's been in there for years. There's a workbench in the back with power. It's a mess, but it's quiet." He took a long drag from his cigarette. "As for parts, my inventory logs are a work of creative fiction anyway. You give me a list. I'll see what gets accidentally marked as unserviceable and pending disposal. But you keep my name out of it. And if Bulldog's MPs come sniffing around, you're on your own. We clear?" "Crystal, Sarge," I said, a wave of relief so powerful it almost buckled my knees. "Thank you." "Don't thank me yet, kid," he growled. "You ain't built nothing yet. Now get out of here. You're distracting me from my zen." Warehouse 7 became my sanctuary. It was a cavernous, dusty tomb, smelling of old canvas and hydraulic fluid, filled with the ghosts of aviation's past. In the far back, under a single bare fly-specked light bulb, was my workbench, and for the next 6 months, it was my entire world. Sully was as good as his word. Components started appearing. Early generation transistors, analog to digital converters, gyroscopes pulled from defunct missile guidance systems, a power supply from a Navy radar set. It was a hodgepodge of salvaged, obsolete, and liberated technology. My goal was to build a hardware-in-the-loop simulator, a physical manifestation of my analog computer model. I wanted to feel the system work, not just see the numbers. Sully helped me salvage a complete control column and rudder pedal assembly from a crashed F-100. We mounted it to the workbench. I spent weeks designing and building the interface, the circuits that would translate the physical movements of the stick and pedals into electronic signals. This was the pilot's input. Then came the heart of the machine, the black box, my flight control computer. It wasn't a single box, but a sprawling, ugly rat's nest of circuit boards, heat sinks, and wires spread across half the workbench. There was no integrated circuit powerful enough to do what I needed, so I had to build the logic from scratch, using dozens of individual transistor boards, each one a separate part of the control algorithm, one for pitch, one for roll, one for yaw, all feeding into a central gain scheduler that would adjust the stability based on simulated airspeed and G-load. It was a digital brain built with analog parts, a temperamental heat-generating monster that constantly threatened to short out or drift out of calibration. Sully was invaluable, his decades of practical experience solving problems my textbooks never mentioned. He showed me how to shield the sensitive analog circuits from the electrical noise generated by the power supply, how to hand-match transistors to create stable amplifiers, how to build redundancy into the critical pathways. He was the master craftsman. I was the mad architect. The final piece was the output. We found an old green screen cathode ray tube display, the kind used in early air traffic control consoles. I programmed a simple wireframe representation of an aircraft and a horizon line. The black box would take my stick inputs, run them through the unstable F-100 aerodynamic model, apply the artificial stability corrections, and then output the resulting aircraft attitude to the screen. In theory, I could fly the unstable plane, with my electronic safety net catching me thousands of times per second. The first time we powered it all up, it was a disaster. The screen was a blizzard of static, the control box let out a puff of acrid smoke, and we blew every fuse in the warehouse. For a month it was a cycle of frustration and small victories. We'd solve one problem only to discover 3 more. The system would work for 5 minutes, then drift into an uncontrollable oscillation. Bulldog's words echoed in my head. You'll crash every plane. I was crashing a simulated one, over and over, every single night. I was starting to believe he was right. The breakthrough came, as it often does, at 3 a.m., after a 16-hour day, when I was on the verge of giving up. The problem was feedback, a microsecond delay between the sensors and the actuators in my simulation that was creating a vicious cycle of overcorrection. I spent an entire night rewriting the core control law, adding a lead lag compensator, a predictive element that anticipated the aircraft's motion instead of just reacting to it. I uploaded the new code. I strapped myself into the salvaged pilot's seat. I took the stick, and I flew. It wasn't a fight anymore. It was a dance. The wireframe plane on the green screen was perfectly, beautifully, unnaturally stable. When I let go of the stick, it stayed locked on the horizon. When I banked, it responded instantly, precisely, with no overshoot, no oscillation. Then, I flipped the switch I had labeled Combat Mode. This was the magic. The program instantly relaxed the artificial stability, allowing the plane's natural instability to take over. The change was breathtaking. The simulated fighter was no longer just stable. It was alive. It was a hummingbird. A thought in my mind became an instantaneous movement on the screen. I could perform snap rolls, impossibly tight turns, Cobra-like post-stall maneuvers that the real F-100 could only dream of. I was balancing the broomstick. My black box, my electronic suicide pact, was working. For 2 hours I flew in a state of pure, joyous exhilaration. Sully just stood behind me, silently watching, a slow, rare grin spreading across his face. "Well, I'll be damned, kid," he finally said, lighting a cigarette. "You actually did it. You taught the broomstick how to fly." I leaned back, my body drenched in sweat, my hands aching, but my mind soaring. The simulator was proof, but it wasn't enough. It was a ghost in a machine. To convince Bulldog, to convince the Air Force, I needed to make it real. I needed to fly it in the real world. "It's not enough, Sully," I said, my voice hoarse. "This is just a video game. To prove this, we need a plane. We need a real test bed." Sully's grin vanished. "You're crazy, Holloway. Bulldog wouldn't let you near a lawnmower, let alone a multi-million-dollar fighter jet. He'd see you court-martialed and buried so deep your own mother wouldn't find you." "I know," I said, my eyes still locked on the screen, on the perfectly balanced wireframe fighter. "So we don't ask him for a fighter." Sully raised an eyebrow. "What then? A Piper Cub?" "No," I said, a new, even more insane idea taking shape. "We ask for a drone, a target drone, something they already expect to get shot down, something they see as expendable." I turned to him, my eyes wild with the terrifying brilliance of the next step. "We need to convince them to let us put our black box into something they're already planning to crash." Sully spat a stream of tobacco juice onto the grimy concrete floor of Warehouse 7, the sound echoing in the cavernous space. "A target drone," he repeated, wiping his mouth with the back of his hand. "You want to put your Frankenstein's monster, your crash-every-plane black box, into a drone?" He shook his head, a mixture of grudging admiration and utter disbelief on his face. "Holloway, you got balls bigger than a B-52's landing gear, I'll give you that. But even a drone, that ain't just some radio-controlled model airplane. We're talking QF-104s out here, Mach 2 starfighters, stripped down and flown remotely. They crash 'em for missile practice, sure, but they ain't exactly toys. They got flight systems, autopilots. You try to patch your homebrew electronics into that, without authorization, Bulldog finds out." "He won't find out," I said, the plan solidifying in my mind, fueled by the adrenaline of the simulator's success. "Because we're not telling him. Not the whole truth, anyway." Sully raised a skeptical eyebrow. "Okay. Professor, how you figure we pull that off?" "We waltz into the drone program office, say, 'Hi, we're the guys the Chief of Stability and Control thinks are trying to kill pilots. Can we borrow one of your supersonic jets to test our illegal black box?' They'll laugh us out of the building, right before they call the MPs. "No," I countered, pacing back and forth in front of the workbench. the pieces clicking into place. We don't frame it as a flight control system for piloted aircraft. That's Bulldog's turf. That's the heresy. We frame it as something they need. Something safe. Something boring. I stopped pacing. Sully, what's the biggest problem the drone guys have with the QF-104s? Sully thought for a moment, scratching his greasy chin. Well, aside from them being hangar queens always breaking down, control. Especially landing them. They fly them remotely, right? Trying to land a Mach 2 beast like the 104 with a joystick and a TV screen. It ain't easy. They lose more drones to landing accidents than they do to missiles, wrecked gear, runway overruns. It's expensive and embarrassing. Exactly, I pounced. So, we don't propose a revolutionary flight control system. We propose an automated precision landing augmentation system. APLAS. Sounds official, right? Sounds safe. Sully slowly started to grin. You sneaky son of a bitch. Think about it, I continued, the idea flowing now. Our system, with its fast-acting electronic controls, its precise sensor feedback, it's perfect for automating landings. We can program it to execute a perfect flare, a perfect touchdown, every single time, regardless of crosswinds or pilot operator error. We tell the drone program office we have a prototype system, developed using advanced simulation techniques. I patted my jury-rigged simulator that could drastically reduce their landing accident rate. We emphasize the safety aspect, the cost savings. We frame it as a way to make their existing drones more reliable, more expendable. And the relaxed static stability part, the unstable broomstick magic, Sully asked, the grin fading slightly. We don't mention it, I said flatly. Not yet. Phase 1 is APLAS. We prove the hardware works. That our electronics can safely interface with and control a real high-performance aircraft during its most critical phase of flight, landing. We build trust. We demonstrate reliability. Once the system is in the plane, once it's proven, it won't just fall out of the sky. I let the implication hang. Once the hardware was accepted, then we could start exploring the more radical flight modes, the RSS, the enhanced maneuverability. But we had to get our foot in the door first. We had to Trojan horse our revolution, disguised as a boring landing system upgrade. Sully was silent for a full minute, chewing on his unlit cigarette, his eyes narrowed in calculation. He was running the angles, the risks, the potential bureaucratic loopholes. Okay, he finally said, it's still crazy. It's still probably gonna get us both busted down to Airman Basic and sent to Antarctica. But it's smart crazy. I like it. He spat again. All right, Holloway. You write the bullshit proposal. Make it sound real dry, real boring. Lots of acronyms. Charts showing potential cost savings. I'll, find some technical reports on QF-104 landing incidents to back it up. And I know a guy, a warrant officer over in the drone squadron, owes me about 1,000 favors. Maybe. Just maybe. We can get this APLAS proposal onto the right desk without Bulldog's office ever seeing the damn thing. The next month was a blur of calculated deception. I wrote the driest, most jargon-filled, mind-numbingly boring technical proposal of my life. I filled it with charts based on my simulation data, carefully cherry-picking the results that emphasized stability, augmentation, and precision control during the landing phase, while conveniently omitting the data showing the system's ability to handle extreme instability. Sully, meanwhile, worked his magic through the enlisted network, the back channels that bypass the officer corps. He called in favors, traded war stories, and probably bribed someone with a case of scotch. He managed to get our APLAS proposal slipped into a pile of routine modification requests going before the Edwards Test Wing's internal review board, a lower-level body focused on range operations and support equipment, not fundamental flight control research. Bulldog Johnson wasn't on that board. Our Trojan horse was built. The review meeting was a low-key affair, held in a stuffy trailer near the drone hangars. I wasn't even allowed in. I was just a civilian engineer, and this was an operational review. Sully went in alone, armed with my boring charts and his decades of hard-won credibility as a master technician. I waited outside, pacing in the desert heat, convinced that at any moment Bulldog would burst in, alerted by some sixth sense, and denounce us both. An hour later, Sully emerged, squinting in the sunlight, his face unreadable. "Well?" I asked, my voice barely a whisper. Sully just shrugged, pulling out a cigarette. "They bought it." I stared at him. They bought it? Just like that?" "Pretty much," he grunted, lighting the cigarette. "Old man Henderson over there." He jerked his head towards the drone squadron hangar. "He hates losing drones on landing. Costs him budget points. Your chart showed a potential 80% reduction in landing accidents. He practically bit my hand off." He took a long drag. "Got you funding?" "Not much. Enough for parts, some bench time. And you get one airframe. An old QF-104, tail number 560791. She's a hangar queen, always got electrical gremlins. They figure if you screw it up, no big loss." He blew a smoke ring. "You got 6 weeks to integrate your APLAS system and prove it works in ground tests. Then, maybe, they'll let you try an actual remote landing. 6 weeks, one plane. A plane notorious for being difficult to fly even with a pilot, let alone remotely. A plane with known electrical problems, and we had to integrate my untested, unproven Frankenstein's monster of a black box into its core flight control system. The elation of getting approval was instantly replaced by the crushing, terrifying weight of the task ahead. Warehouse 7 transformed again. It was no longer just a secret lab. It was an ad hoc aircraft integration facility. Sully somehow managed to get 0791 officially transferred to his depot for routine maintenance, parking it in the darkest, least visited corner of the sprawling warehouse. And we went to work. This wasn't simulation anymore. This was real hardware, real hydraulics, real bundles of cannon-plugged wires carrying lethal voltages. We weren't just interfacing with salvaged parts. We were tapping into the actual flight control actuators of a Mach 2 jet. The risks were astronomical. A miswired connection, a software glitch, a voltage spike, could send the control surfaces hard over, could trigger an uncommanded engine shutdown, could, as Bulldog had so gleefully predicted, crash the plane. We worked with a kind of focused, terrified intensity. I practically lived in the cockpit of that old starfighter, tracing wires, installing sensors, interfacing my black box, now rebuilt into a more robust, rack-mounted unit, with the drone's remote control receivers and the aircraft's own internal systems. Sully, with his encyclopedic knowledge of military avionics, was indispensable, figuring out how to splice into the complex, poorly documented control harnesses without triggering fault codes or frying irreplaceable components. We weren't just engineers, we were surgeons, performing open-heart surgery on a sleeping dragon. As the 6-week deadline approached, the pressure mounted. We hit snag after snag. Power fluctuations in the drone's ancient electrical system kept crashing my processor. Interference from the high-power command radios messed with my sensor readings. The interface with the hydraulic actuators was sluggish, not as crisp as in the simulation. Bulldog's prophecy echoed constantly. "You'll crash every plane." Every glitch, every setback felt like confirmation that he was right, that my ambition had outrun my ability, that this whole enterprise was doomed. But we pushed through. We added power filters. We shielded cables. We rewrote code on the fly, compensating for the hardware's imperfections. Finally, after countless sleepless nights, after running the system through thousands of simulated landings on the hardware in the loop rig, after checking and double-checking every connection until our eyes burned, we were ready, or as ready as we'd ever be. Sully signed off on the ground tests. We powered up the QF-104 remotely from a control van parked 50 yards away. We ran the engine, we taxied it, and then, holding our breath, we engaged APLAS. We sent the command for the system to wiggle the elevators, the ailerons, the rudder. Inside the van, watching the telemetry on a fuzzy black and white monitor, we saw the control surfaces move, smoothly, precisely, exactly as commanded. The system was responding. It hadn't crashed, it hadn't blown up. Phase 1 was complete. Sully looked at me, his face grim, but a tiny spark of something, maybe hope, maybe just sheer lunatic excitement, in his eyes. "Okay, Holloway," he grunted, clapping me hard on the back. You taught the box how to talk. Now, you gotta teach it how to land. And pray to God, you didn't just build the world's fastest lawn dart. The next step was the first flight test, the first real landing. And Bulldog Johnson, alerted by the drone squadron commander about the upcoming APLAS test, had just put himself on the official observer list. He was coming to watch. He was coming to see his prophecy fulfilled. The day of the first landing test dawned clear and cold over the high desert, the sky a harsh metallic blue. The atmosphere around the drone control van wasn't celebratory, it was funereal. Colonel Bulldog Johnson was there, standing in the back, arms crossed, radiating an aura of grim, I-told-you-so certainty. He wasn't just observing. He was presiding over what he clearly believed would be the fiery, career-ending crash of my ambition. Warrant Officer Henderson, the drone squadron liaison who had tentatively greenlit the test, looked pale and nervous, clearly regretting his decision. Sully stood beside me at the control console, chain-smoking, his face an unreadable mask, but the tension radiated off him in waves. My own hands were slick with sweat, my heart hammering against my ribs like a trapped bird. This was it. 6 months of secret work, years of theoretical obsession, all riding on the next 10 minutes. 0791, the old QF-104 starfighter, our designated sacrificial lamb, was already airborne, flown remotely by a nervous drone operator to 15 USN feet 5 miles out. The plan was simple. The operator would fly the approach down to 500 feet, line it up with the runway, and then hand it over. Hand over a Mach 2 fighter, dirty with gear and flaps, wallowing at low speed, to my black box, to APLAS, to the electronic suicide pact. Ghost Rider 791 on final approach 5 miles, gear down, flaps set. The drone operator's voice crackled, tight with tension. Airspeed 180 knots, APLAS. Standing by. My fingers hovered over the keyboard. This was the point of no return. Engaging the system meant my code, my logic, was now physically connected to the hydraulic actuators controlling the elevators, ailerons, and rudder of a 12,000-pound jet fighter hurtling towards the ground. Bulldog's words screamed in my head. You lose power. A short circuit? A vacuum tube blows? We were using transistors, but his point remained. He dies. Instantly. Except there was no pilot on board, just my reputation, Sully's career, and the future of flight control. Engage APLAS, now, Henderson authorized, his voice barely a whisper. I took a breath, typed the command, hit enter. A single green light blinked on my console, APLAS active. On the fuzzy monitor showing the drone's telemetry, we saw the control surfaces give a tiny, almost imperceptible wiggle as my system took command, performing its initial self-check. So far, so good. It hadn't immediately nosedived into the desert. APLAS has control, the drone operator confirmed, his voice filled with a mixture of relief and sheer terror. She's flying. The next minute was the longest of my life. We watched the telemetry, watched the altitude unwind, watched the airspeed indicator hover precariously close to the starfighter's notoriously high stall speed. My system was flying the plane, making hundreds of tiny, invisible corrections per second, compensating for wind gusts, keeping the wings level, holding the glide slope with unnatural precision. It was too smooth. It didn't look like a plane being flown. It looked like a simulation. Bulldog leaned forward, his eyes narrowed, scrutinizing the data feeds, looking for the flaw, the oscillation, the impending failure he knew was coming. The runway threshold rushed up on the monitor. 50 feet, 40, 30, the operator called out. Now came the critical part, the flare. Landing a starfighter was famously difficult even for human pilots. Its tiny wings required a high approach speed and a precise last-second rotation to bleed off energy without stalling or slamming into the runway. Could my code, my logic, replicate that delicate, instinctive maneuver? Flaring, now, I whispered, watching the elevator deflection graph on my screen. The line spiked smoothly upwards. On the monitor, the nose of the QF-104 rotated perfectly, gracefully. 20 feet. 10. Chirp. Chirp. The sound of the main gear kissing the concrete, relayed through the telemetry microphone. A perfect touchdown. The nose gear settled. The drag chute deployed. The drone rolled out. Straight down the center line, slowing smoothly. It hadn't crashed. It hadn't even bounced. It was, by any measure, one of the smoothest, most perfect starfighter landings anyone had ever witnessed. The control van was silent. Utterly, profoundly silent. The drone operator just stared at his screen, his mouth open. Henderson let out a long, shuddering breath and sank back in his chair, wiping sweat from his forehead. Sully slowly, deliberately, crushed his cigarette butt under his heel, a huge, slow grin spreading across his face. And Bulldog Johnson, was just standing there, frozen, his arms still crossed, but his face was a mask of shattered disbelief. He looked like a man who had just seen a ghost land a spaceship. He slowly, mechanically, uncrossed his arms. He walked forward, leaned over my shoulder, and stared, not at the telemetry, but at my console, at the simple blinking green light. Applis active. He looked at the lines of code scrolling past, the thousands of tiny corrections my system had made, the silent electronic sweat that had produced that perfect landing. He didn't speak for a full minute. Then, he cleared his throat. "Holloway," he said, his voice rough, gravelly, almost unrecognizable. He didn't congratulate me. He didn't apologize. He just asked one simple, world-changing question. How soon? How soon can you teach that box to fight? The war for fly-by-wire wasn't over, but we had just won the decisive battle. My joke, my electronic nightmare, had just landed its first plane. The Records pilots would break later in the F-16, the F-A-18, the F-22, every agile, unstable, fly-by-wire marvel that followed. They all started right here in this dusty van, with this one, stupid, perfect landing. The future had arrived.